Hello everyone. Today we are going to see how to make water jet distribution network. There are so many videos available on the YouTube, but I never seen anyone told us about basics of water gems. So we are going to cover that area. So let's start. First of all, uh, you should have two files. Where first is DXF file where we are going to build model on. So first, this is your WaterGEMs file, and this is WaterGEMs model builder. So we click on the model builder, and this pop-up will show, and then you have to click on new button. So new, then this model builder another pop-up will show where you have to select the data type. We have data type in CAD file, so we will select the CAD file. Next, it will ask you the source. To select source from browse, and you have to click the center line. This center line is a model. Now there's nothing you have to do. Then click next. It will ask you uh, source unit. So we have the source in meters, so we will click on meters. Then you have to click on the checkbox, and it will ask you the tolerance. So we will put 1 tolerance. It means if there is gap between two lines, it will connect the gap with 1 meter length. Then you have to click next, another next. Then it will ask you the properties of the line. We are going to import the line, so it does not contain any other property. So we will give the property like label, and click on next, and there will be two options, yes or no. Would you like to build and model now? We are going to click yes and finish. Again X, again yes. Then zoom and extend. So you will get the basic of the model we are uh, imported just now. So after that, we have to clean the model. How can we clean the model? Here we can see this is the single line, but there is junction in between, but junction is not connected to the pipe. So that's what we are going to do. We will connect the pipe. This pipe is not connected to the main pipe, so this is part of the cleaning process. So we are going to do, how can you connect the pipe? You click on the junction, and then click right click, then you will get the split button. So click on split. The pipe will be split and junction will be connected to the network. So you have to do the same here. But if the model is too large, so you can use the shortcut. The shortcut is in tool. Click on the tool, you will get the more button, and you will get the batch pipe split. When you click on that, it will get the three options. You click on all and OK. It will split all the candidates. So after splitting, we are going to confirm that all the pipe has been split. Then the remaining pipes you have to attach manually. Yeah. There is junction in between the pipes. How can you remove it? You click on the pipe, right click on the pipe, and you will get the reconnect button. So click on the reconnect and place on the another junction, and just delete the in between junction. So this is very easy. Now we are going to place the OHT location. So just assume you have OHT in here. Okay, so how can you put OHT? Go on the layout, you will get the tank. Click on the tank and place it on the junction. It will ask, would you like to move junction into tank? Click on S. You will get the OHT. So after that, these junctions doesn't have any elevations, so we have to provide elevations by going on tools. We click on the T-Rex. Okay, click on the T-Rex. It will ask the data source, which type of data do you have. We have DXF point. Click on the DXF point. It will ask the file location. Click on the elevation, open, and then select elevation field. It means what is the type of elevation. It is name, color. We need elevation. So XY unit, which is meter, Z units, which is meter. All set. Now click on next. Click on OK. We have all the elevations. Click on finish. Now we can see we have elevation on the all the junctions. You can see by going home, click on flex table, go to the pipe, go to the junction where you can see the elevations. We are going to see by sorting ascending, we have all the elevations, right? After, we have to put the OHT elevation. So if you have this point elevation, you can put it there or just put it manually. I'm going to put it 190.5. okay, 190.5 elevation. After that, you will get operating range. These four options you have to fill. First is the same as the elevation. Put the 190.5. Then elevation minimum. Elevation minimum. It means provide staging. So we provide 12 meter staging. Okay, calculate 190.5 plus 12, 202.5. 202.5. Okay, then it will ask you the elevation initial. Initial elevation will be minimum plus 0.15 plus 0.15. This is the dead storage considering in the OHT. So we have to add this and 202.65.65. okay. After that, it will ask you the maximum height of the OHT. It means FSL. So FSL is minimum plus the container height. So we will consider 5 meter container height. So it will add up in 202.5 plus 5. Remember, you have to consider minimum, not initial level. 207.5. Now we have to click on refresh. So we will get the GL and the staging of 12 meters. Okay. So we give random name OHT, something like sample OHT. Provide sample OHT. Okay. Consider capacity 50 KL. This is small distribution, so it is 50 KL. Now we have to all the fields, elevation, OHT. Now we will validate the network. Go to the home and validate. No problems were found. It means you can run the network. So compute. There is no demand. That's why we will get 0. So next step is put demand on the network. How can we put the demand? We need population of this network or village, whatever you are making design on. So we have this population. uh, 1256, which is population of ultimate year, and we have to make convert into MLD or LPS. Okay, so 1.104 we are going to consider LPS. We have to take ultimate year demand. So in LPS 1.104. So go on the tools where you will get the load builder, then new area load data, unit demand, next. Then this window will pop up where you have to generate. It will ask you for K factor field, so simply click on the three dots and say OK. It will create the K factor, then select the K factor and your demand. You will put your demand. It will ask the unit of the demand, so you can put any unit by clicking right click, unit, and formatting. You can change anything like MLD, LPS. So we are going to put the demand in LPS 1.104. Okay, and it will ask you the entire network. Then click on next, again next. It will ask you for any naming. We are providing a name sample. After, override a existing network now, or 7 base demand. You have to always choose the 7 base demand. Click on finish. You will get demand on each of the point. Okay, then again go on home, validate, and compute. So this is the demand. Okay, so it is running with no problem. After that, we have to consider 3 factors only. In rural areas, you will get the guideline of at least 7 meter, provide 7 meter to the end point of the junction. You have to minimum pressure 7, you have to consider 7 meter pressure. So pressure, we are getting pressure 15 meter, 17 meter. It is more than enough. But how can we change the pipeline? This is very small network, that's why you are um, getting so much pressure. But consider you have OST in very low elevation, so we are considering low elevation 80.5, 192.5. So OHT is in 10 meter down. Then we have to again validate and run. So you see there is pressure difference. We are getting 4.3, 4.2, 5.3, 9.4. So we have to increase the staging height, or we can change the pipeline size. Okay, first we are going to rename the pipes. Go on flex table, pipe, and label. Click on right click, relabel, and renumber. Put P dash. Click on OK, and the pipes will be renamed. So in pipeline, go to the pipe table and see the hydraulic gradient. We have to increase the pressures here. So how can we increase the pressure? Go to the hydraulic grade, short descending. You will see the 31, 15, 8. As per CPHU manual, we have to take the head loss below the 4 meter per kilometer. But as per new CPH manual, you can go around about 10 meters. So these are way more than 10. So we have to decrease the head loss gradient. How can we do that? By increasing the pipe size. The lower the pipe size, the higher the head loss gradient. So this is the 63 meter. We are using HDPE pipe. So we have to put internal diameter. Okay. So this is property table. You can get the property table by, we have property table in home button. This is property. You can click on that or double click on the pipe or any element. You will get the property table. So we have to put internal diameter of let's consider 1110. So 97.5. Okay, click on refresh. You will get the 110 pipeline. Now again validate and compute. Okay, so we have to see the head loss now. This is the head loss gradient, which is 2.2, which is way less than we have seen earlier, which 31 point something. Now the below pressures are increased. This is 6, this is 7.4, 6.9. We still doesn't get the 7 pressure on the all the nodes. So we have to again change the pipe diameter, put 80.8, which is 90, and compute 6.5. Now see the flex table. We have the head loss gradient under control, but we still not getting the desired pressure. So we continue to increase the pipe size. We will give 97.5, or you can simply put here. This is 56.6. We will provide 75, 67.3, 67.3, and 67.3. Okay, then click on compute. Now again see the flex table. We still have one more than 4 meter per kilometer head loss gradient. So we have to change the diameter again, 80.8, which is 90. Now click on compute. Now we can see the pressures are increased now. Go on flex table, junction, and pressures. This is the pressure head. Go short, ascending. Minimum pressure is, you can zoom by clicking on this icon. So this is the last point and you are getting 4.8. So elevation difference is 7 meter elevation difference. We have elevation on tank is 180.5 and this is 187.42. So we have to increase the tank staging. Calculate 187.42 minus 180.5, which is 6.92, plus how much pressure we need in that junction, plus we need 7 meter in that junction. So click on 7. So at least this is the Staging we need 13.92, so we will round figure it into 4, 14. Click on OHT, add 2 meter. So we will refresh. So OHT staging is 14 meter now. Now compute, you will get the 6.8. Now we are going to see how much losses we are going to face in this pipe. Head loss is 0.9. There is chance we can increase the pipe size by 67.3, which is 75. If you still doesn't get the desired pressure, you can increase staging by 1 meter as well. We are giving 1 meter. Okay, now staging is 15 meter, and when we compute, we will get the 7.8, which is perfect. So this is the basics of WaterGEMs. You can make it very easy without any problem facing. If you want to enhance the model, you can provide sluice walls, which we are going to talk about in next videos. So thanks for watching.